Hey everybody, how are we doing? Good to see you here, Mohammed. I'm about to hear myself twice because I was listening to it. I like the Marvel intro so much, but Marvel's always interested in us playing it. Can you go over the next assignment for BAS 320? You bet. Do we have that posted? Let's go take a look. Last night was so busy. Thank you for everyone for all your hard work. I can't state this enough. Mohammed, thank you. I know you're working hard on the assignments. I know everyone else is. Lot going on in the world today, as always, but I mean, 2020. And we're here to help, though. We're here to kind of give guidance on the assignments, to teach the material, and really, I appreciate all the hard work. And just please, once again, I want to say this very, very loudly. If you need anything, if you have questions, if you have concerns, just talk to us. I've been trying to work with as many students as possible, which is all of them. That's what's possible, to help out with any concerns, because I know there's a lot going on right now. And so, we got a saying. Mubot knows what's going on as I get the assignment load on. Is it this Mubot? Is that what we say? Mubot, you there? Yeah, that's good. But we got another saying, Mubot. Mubot, vols help vols. Vols help vols is what I'm looking for, Mubot. Well, let's get the assignment loaded up here, Mohammed. Good to have you. We all know vols help vols. That's one of there. Thank you, Mubot. Mubot knows what's happening. Let's go here to the assignments. And we don't have the association's assignment posted yet. Were you wondering about that, Mohammed? I don't see it posted yet. So we don't. I was like, did we post it? Because I was helping out. Hey, what's up, Danny? Good to see you here. We don't have it posted, but I could kind of give a preview of it because I got to get this finished up today. How about we do a preview of it? How does that sound? We kind of give a preview and we talk through it. And it's like we can call these like preview of next homework assignment. And then this isn't out yet. It's not published. It says you can't release this yet because, okay, let me put some due dates on this. Let's see here. Next Thursday, due date of the assignment. Gonna get this done later tonight. Not publishing it though, because I need to clean up the assignment. This is the song, the clean up the assignment song. Let's go. Let's do it. Let's get a preview of this assignment. Let's get a preview. We're gonna put preview homework 3 preview. That way, if anyone's watching this video, we need to put like the warning thing over. I created like this warning animation. I don't have it ready to go. I can't use it now. Thursday. That's what the days in the world is getting all mixed up. 2 seconds. We'll be ready to go here, Mohammed. And this is a really good topic, Mohammed, for like what are we gonna be doing? Okay, so let's do this. Let's hop into it. Let's get this going. You ready, Mohammed? Here we go. 3 minutes in. Let's do this. I do exist over here. I was trying to label these like, oh, that's Brawl. I was trying to label these, and then I couldn't. Yeah. But then they're all the same names. So I was like, darn it. Okay. So this is a preview. Please note this is a preview. These are possible questions. I might be making some changes to these. If you're looking for where the homework questions are taken from, we take homework questions from the book. I suggest having the book. The book is good, but you're not required to buy the book, which is one of the things I like about this class. That the book is optional because college is expensive. I know that. And it's just gotten more expensive. So if you feel like if you're learning well enough by using the homework packet, we're okay with that. And so the homework packet is out there for this class, so you don't have to buy the book. So the homework packet is posted. I guess I can show that. For those wondering where the homework packet questions come from, you can go to the modules on Canvas, and you should see right here, homework packet. So the homework packet right here, I can't make that clear enough. Here's where you can watch class for your sections. Here's extra credit form. Here's the homework packet. So you don't have to buy the book, even though I think the book is excellent. It's a very easy read. Does anyone have the book in chat right now? Mohammed, Danny, anybody have the book? If you have the book, I've read it. It's Dr. Petrie wrote it, and it's very easy to read. It's just, how to code and understanding what we're doing. And it's written just at a level that I think, really makes it understand. No, and that's all right. If you don't have the book, no worries. I think it's very easy to read, but we do post the first chapter of it. So that way, if you're ordering the book, you don't have to worry about like, oh, I just ordered the book and class is, I have to wait for it. We post the first chapter of it. Do I still have that up? So we should have, well, I closed it. Well, darn. And we have the homework packet posted. So let's talk about this though. Okay. Oh, they're all homework packet questions. We got to go to the homework packet. I kind of thought it would be. I kind of know some of them from memory. So this one right here, I know some of the questions from memory. So here we're going to kind of do some memory questions. You ready? Brian's going to do questions from memory right here. Okay. So let's first talk about what line 109 is. What line 109 is, it loads the library. The library is basically things that load up into R that we have access to. If you run this line of code, you'll see this red text. Don't worry, that's just telling you things have been updated, that certain things are loading up on your computer. These are not warnings, they are not errors. It's just telling you, hey, random forest is this, and R part is this, and splines is this, and we're loading packages. Required means that it's like, this is required to be loaded so that reg class is loaded. So you didn't ask to load VGAM or leaps, but it's telling you, hey, we're loading these up in the background too because they're required for reg class to work. Down here, you just have some additional kind of warning notes saying like, hey, this has changed to this. Core.demo is now core_demo. Core.all.correlations is now all_correlations. That's weird to say. So you can check out some of these functions right here by going all_, and there's the all_correlations function. One of the coolest ones, though, which we will be using quite soon, is the core demo. Core demo is kind of neat. You should run core demo down here. Core demo takes no arguments, and it does a correlation demo. I might need to zoom out just a little bit to make this look decent. So different graphics require different kind of zooms to make them work really well. So you'll notice right here with the core demo, you can actually do correlation over here, and you can actually get both R and R squared. And so this is kind of a review, and these are some of the topics we'll be covering very soon. So this is kind of a preview into this assignment and also a preview into the new topics. Now, look at the correlation right here. The correlation right here is 1, meaning that it is perfect positive linear correlation. Now, who knows some stats 1? Gosh, I'll throw 1,000 additional points if someone knows the 4 ways to talk about correlation. I'll give 1,000 points if someone just gives it a good shot. Who knows who's watching right now? I'll get someone to interact right here and be like, who knows? I should not have gone to 1,000. What have I done? I said it. Who wants to give it a good shot right here? The 4 things for correlation. So go back to Stat Tool 1. If you have a notebook, go grab it real quick. Grab that Stat Tool 1 notebook and be like, how do we talk about correlation? Correlation is bivariate quantitative. So it's an association. There is p-values for correlation. Mohammed, you give it a shot. I said the 1,000 points. You got it, Mohammed. Great job. So the 4 ways we talk about correlation. Well, 1, it's quantitative variables. That's not how we talk about it, but the only way when you're doing correlation, we mentioned this in class last time, correlation is for 2 quantitative variables, such as if X increases, Y also is correlated as in an increase or decrease. And so the 4 ways we talk about this type of a association, which is this homework we're doing, is we talk about strength, direction, form, and unusual features. Strength, direction, form, and unusual features. And so we can kind of do a mini lesson on this. It never hurts to make sure we know what's going on. A mini lesson on this. Let's take a look. This is kind of an intro to what we'll be doing next week, and it'll help with a lot of the topics we'll be covering. So when we talk about strength, what is strength? Strength, so it's one of the 4 things. It's going to be the vertical spread within a scatter plot. So strength is the vertical spread within a scatter plot. So let's go right here and talk about some weak strengths. So we could have some very weak strengths right here. Let's draw a few. That is very weak. That is a very weak correlation. This one also right here, there might be something going on right here, but it's got a lot of vertical spread. I made it a little stronger, but it's still pretty weak. Now be careful. here's where we get to the interesting part. Let's make it stronger right here. Let's make it super strong over here, and hopefully I'll only have one. We need 2 examples. That's the problem. There's a caveat to this. There's an interesting part to this. So the strongest would look something like this, like the one I was kind of drawing. This is like super strong because look, there's no vertical scatter here. Notice how right here we don't have any vertical scatter. There's no vertical scatter where there's a bunch of vertical scatter in here. But check this out. Here's where people get confused. Both of these relationships right here, and this doesn't have a real good correlation, but both of these associations, relationships, are super strong because strength is the vertical spread of a scatter plot. And look at the vertical spread of this. And we're talking about within a certain like range of X values. Because you might say, well, isn't the vertical spread this? Well, then wouldn't the vertical spread be that there? We're talking about within just this range of X. Look how I'm drawing like a vertical spread around that range of that X. It's so tight, it's extremely strong. As in, if I were to tell you there's a new point that exists between these 2 points, where do you think it would be? Between these 2 points right here. I'm using the wrong pen. Between these 2 points, there's a new point. You'd be like, well, obviously that point is probably going to be here. I mean, you'd have a good guess because it's so strong. Strength, direction, form. Yes, Mohammed, that's what we're meant to do right now. That's what we're doing. And this is new stuff we'll be covering very soon. And then if you were to go over here and say there's a new point somewhere in here, or we could go to like an area we didn't do. There's a new point in here. You'd be like, well, I don't know. Where could that be at? I have no idea. I mean, I don't have a good understanding of where that would be at. Then we're going to drive our conclusions. Yep, we're going to use this right here to kind of understand that, you could have something that's moderate. So here's a moderate. It can be nonlinear. Strength only speaks to the vertical scatter of it. So these are getting stronger, and linearity is a different thing. That's the form of it. So the vertical spread is the strength. Linearity is not what we're talking about here. The tighter the vertical spread, either linear or nonlinear, is going to be the strength of the scatter plot. So we understand what strength is right here. Very important. We do not confuse this with the 4 other things because that's where people make mistakes. And next we would have strength, direction. Direction is really easy. Direction is just, does it go up, down, or neither? So up, down, neither. Like it's pretty easy. So when you get to, hey Brian, after this, would you be able to go into on the 470? You bet. Yeah, let's do that. We'll do that next year. I'll go over strength, direction, form, and usual features. Kind of a good and good review here, Emily, because we use this some in 474, but this is classic stuff right here. Like, I was literally watching, and they were like, "Hey, do you want to join this online thing to learn how to do things like regression?" I was like, "Hey, that's what we do." They're teaching regression. They were like, "You can." It was an ad on YouTube. So direction is going to be like positive, up. You can call it positive. You can call this one negative, or neither. You can call it both. You can call it neither. Either word's fine for that. It doesn't really go in one clear direction. I guess neither might be more something like, you might think of neither more classically like this right here. Like this really doesn't have a direction. Like something like a blob would kind of be neither, and I guess the parabolic relationship might be better described as both. I mean, we really care more about the positive or the negative, but neither or both are kind of like, it's not well described by an up or down, positive or negative. So let's put that right here. Let's put a quick up is simply positive. I think most people would know that, but never hurts just add it into our notes that we can describe that as it goes up, it's positive, or it goes down, it's negative. And so, when you think about what negative correlation means, is as X increases along this axis right here, then Y is going to decrease in its value. Y is going to decrease as X increases. So, and once again, this really doesn't have to be linear. We should mention right here that we're not talking about the linearity of it, because you could have a general positive series right here that generally goes up, and you could have a general negative series here that generally goes down, but has some nonlinear characteristics to it. So the direction speaks to the overall pattern in the data. And again, we're not talking about the strength of it, because we could change this to a weaker thing, but it's still positive. This is now weaker, changing the strength, but we're just talking about the direction it goes in. Direction does not speak to the strength. The strength is the vertical scatter. The direction is going to be just the general direction of the relation. I mean, I say, don't worry, I say this, and then just they don't go together. Like, I don't know. Hopefully that makes it clear with these plots right here, what's happening with the direction right here. And this is all associations for quantitative variables. Let me make this, we need to put one more heading on this. Yes, it did it. And we got two more things to talk about, and then we're going to go to 474. You got it. So associations between two quantitative variables. And thank you everyone for being here on the Friday. Sorry I moved back the hours a little bit. Really great. We had a Forum Friday and really great. Why'd you let me do that with the other ones and not this one? We had a really great conversation about just how we're helping our goal really, and I want to make this abundantly clear. Our goal is the students, and our department has made that abundantly clear that it's both what is our faculty doing for education and how are we connecting them to corporate partners like Procter & Gamble, like Pilot, like Tremel. We've got a lot of corporate partners very interested in both meeting with our students and internships for our students and helping students apply their degrees. And, I really, as I try to move these images, it worked last time. There we go. I think that's going to do it. Oh, really? We broke it. What did we do? What in the world just happened? You know what I might have to do? Okay, so we got these right here. I don't even know what just happened. Okay, there's the first view, and here's the next view. Let's do the next two. We have strength direction, and now let's do form. So form. Form's the easy one. Form's one of the easy ones. Form. So let's do this here. Form. Linear versus non-linear. So, think about this. Something's either a line or it's not a line. Something's a line or it's not a line. That's all it is. So when we talk about whether something's a line, you're basically asking, is it well described by a line? Because is anything perfectly a line? Okay, technically, I did make a perfect line right here, apparently, because it has a correlation of 1, which is perfect positive. But most things, pat myself on the back. I was really happy when it was 1. I was like, yes, that's what I was going for. So right here, we have something that is linear, and we'll draw something mostly linear. Like, this is mostly linear. Maybe it's got a little non-linearity at the end, like it does like that. But this is mostly linear. And then you've got something that might be a little less linear. Like it starts to, I might say at this point, that one has a bit of non-linearity at the end. And then you have things that are definitely not linear. So with a lot of these things, you want to think of them as a gradient. You want to think of, is it well described by a line? The middle one, I'd say I'm leaning towards yes, but we'll put here that this is linear. And so does the line well go through it? Does the line well go through it? Does the line well go through it? And this is linear question mark. And this is nonlinear. It's a gradient. We do have ways of testing this. We do have goodness of fit tests. So there are ways to examine to see if a line is the correct fit for the data. And we'll go more into detail when we get to regression on that. But a lot of times these tests are very powerful. For any statisticians watching, they'll know what I'm talking about. Powers the ability to reject the false null. And the line's probably not the right model because all models are wrong, but some are useful. Thank you, George Box. And so with that, we're probably going to figure out that the linear model is not the accurate real model because no model's the real model. In other words, we're probably going to reject the null. And that's why a lot of times, and I just want to state this because why did I go through that whole big explanation right there? A lot of times what we're going to do is we're just going to look at it and be like, that line kind of goes through that data. Because if you have 10,000 data points and you're fitting a linear model, I'd be shocked if you don't reject the null. The statistical power on that, the ability to reject the null is going to be so high. At this one, models really got the residuals are really out of, I'm probably leaning towards no now. The more I look at it and I look at this area and the residuals being so bad right there, and this one is a no. So that's what we kind of do, especially with the understanding of how statistical power works. Just sometimes you have to make a judgment call because all models are wrong. So strength, direction, form, unusual features. Unusual features. we pretty much have like, like gaps and outliers. We mentioned gaps and outliers in 201. So we've got outliers right here. And this is very important for 201 and 320. Like this is big 201, 320 talk. 320 would go more in depth on some 201 topics because 201 is like an overview of many topics. So when we get to, oh, we got another one. Why didn't I remember it? Heteroskedasticity. No way did I spell that right. That's what you get for teaching for 10 years on these topics. I learned how to spell heteroskedasticity. So when we talk about these topics right here, we talk about outliers in 201. We even talk about heteroskedasticity. But outliers are going to be, so let's do outliers first. A plot that has no outliers. This is your QQ straight enough, no outliers. There's a really good regression with no outliers. Oh, you bet, Charlie. Ask away. We're going to do a 474 question, but ask away, Charlie. Ask away. Are you doing chapter 5? Ask away. These are open office hours for everybody, and this is something we'll be covering next week in 201 also. So take some good notes on this. This is, you're about to hear QQ straight enough, no outliers. You'll hear that a lot next week. Ask your question, feel free, and I'll answer it. Yes, Canvas Content Quiz 3. Oh, and then a big thing. So which ones are you wondering about on that? Kind of post one of those in the chat, and I'll kind of come up with a different question for it. I'm also on the Kahoot today, going to do a lot of like similar questions and to the Canvas Content Quiz. But put your question in the chat if you can copy paste it. And I'm not going to give the exact answer to that question, but I'll kind of show how to work problems similar to it. So it should be very obvious. So we will do that. We'll do that for the 474 question, Charlie. Thank you so much for asking. Always feel free to drop in and say, hey, Brian, can you work this question? Can you explain this topic? We will do that. So there's the outliers. We want there to be no outliers. And here's the heteroskedasticity. I'll draw it this way. One thing is I took classes from Dr. Seaver, and he always made us draw on our output. Hey, what's up, Trace? Good to see you here. Good to see everybody. For visualization number 5, I put gender into the rows and student loans in the columns. Is this correct setup for the... And then make sure, so Trace, you are correct. You only need now to put on there, you only need to put on there a quantitative. What is not a way to describe a bivariate quantitative? When is this one due, Charlie? And Charlie, I think we've got the answer on the screen. That's so ironic. When is this one due? Because we haven't done chapter 6 yet, and that's chapter 6. Ah, wait. So wait, Charlie, here's some hints. I'm not saying. So Trace, make sure you have a, if you want to send it to me for me to look over, I'll double check. Make sure you're doing the mean of a quantitative variable. Make sure you're doing the mean of a quantitative variable. I think that's where people make the mistake. Can I copy all this? Such a bummer. Ooh, I think I can do it. Oh, no. Oh, let me not do this. Okay. So here's our first thing. Because form, then it's wrong if it's asked. So wait, Charlie, look at this right here. I'll do a quick review, and then we'll do 474, and then I think Trace, hopefully I answered Trace's question. You are correct with your rows and columns, Trace. Great job on that. Those good rows and columns, quantitative values, doing the mean of it, and you'll do that part correctly. Do you see here the strength is the vertical scatter. The direction is if it goes positive or negative. And then the last one right here is the form is whether it's linear or nonlinear. And then in 201, we'll talk about heteroskedasticity as plot does not thicken. So we'll talk about heteroskedasticity as plot does not thicken. So which one do you think it is, Charlie? I mean, we've kind of said it right here. Which one do you think is not? And then I'll kind of explain why it's not that, and we'll do a 474 question. I need to look at the due date on that because that's chapter 6. That is chapter 6. That shouldn't be due till the end of next week. Why is that in this chapter? The Canvas content quizzes are new this semester, and I'm very sorry if... Let's do a review. Shape, center, spread. Shape is talking about skew. I know, it shouldn't. Skew versus symmetry. Skew versus symmetry. Shape also has, let's do Wednesday. We're done with chapter 5, but that's the thing, is we're done with chapter 5. So, well, we're not, yeah, no, good idea. And please ask questions. I don't know why that one's on there, though. I don't know why it's a team effort, and I didn't make this Canvas content quiz on me. I'll just flat out say that. And so I'm like, shape is when you think about the shape of a distribution, the shape of a distribution looks like this right here. So it can look differently, of course. It can look like this right here. Yeah, and that's what's confusing me. I'm like, why is there like one random, talking about bivariate quantitative data? Because the question says, what is a way to not describe bivariate quantitative data? And that's when we talk about, so if you look right here, associations between two quantitative variables. So bivariate quantitative data. So this is bivariate quantitative data right here. Strength, direction. Where's my second one? Form and unusual features. Do you think you have the answer now, Charlie? Because the ways we talk about bivariate quantitative is strength, direction, form, and unusual features. The way we talk about univariate data is shape, center, spread. And so we have modality here also, and modality, that's right, gaps/outliers. So this is the way we talk about, and then the center is going to be mean versus median. And then the spread is going to be standard dev versus IQR. And it's important we know that when we have, here, let's do this. Shape, center, spread is all for, shape is univariate, center is univariate, and spread is univariate. So these are all univariate. And we'll do something right here where, can I add a new pen? They changed my drawing tools. Why? It's a gravel pen. I hate that one. Oh, wait. There is rainbow pen. You know what? We'll use it later. So right now, if the shape looks like this right here versus the shape looks like this, so kind of a very quick review, and we'll highlight these topics. And then, so this is like some quickie review of 201. Can you tell, as I highlight things right here, let's go blue text. Can you tell what I'm trying to point goes together? Like this is like a quick mega review right here. So let's put this right here. I'm trying to make like a mega review cheat sheet for people right here. Like, how can we summarize and make sense of this so that people can see? And so let's do 2 more drawings on this. So right here, the center of the distribution is going to look like this for the mean, and the median is going to look like the 50th percentile. So it's going to look somewhere in here where the mean is going to be inflated. So that's the median. And then the IQR looks like the following. The IQR is going to be the middle 50%. So it'd be a little lower than that if that's where our median is at. It's going to be there to about here, and that's the middle 50%. So that's Q3 minus Q1 and their distance. And this is the median. And this over here is the standard. Oh, I was going to do the next one. That one's there, the mean. So the mean can be notated as this, the mu, the mean of the population. And last but not least, outliers and gaps. Yep, outliers create gaps oftentimes in data. Great job, Charlie. 100 points right there. We haven't been throwing points out this morning. And the standard deviations, we generally draw 3 standard deviations out on the normal curve, which is a good thing to know. And so what you're noticing right here is we just did a big mega review of some Stat 1 topics. So if you look at everything on the screen right here, we do have kind of the ways to talk about univariate data. So just being able to kind of, let's put a note right here. Review of univariate quantitative. So this is a review of univariate quantitative data right here, where we can see a skewed distribution, and that's a right skew distribution, right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. We got to give that monster his little face right here. Go, yep. So right to the high, left to the low, whatever way the tail goes. So z-scores are standardized measurements to measure the center then. Z-scores measure distances from the center. So a z-score, which we can put down here, when we do z-scores, so a z-score is going to be the observation minus the mean over the standard deviation. So these are all standard deviations right here. Like this distance right here is a standard deviation. So that's a standard deviation right there. And this is sigma for standard deviation. And so the z-score is observation minus the mean over the standard deviation. And that's what a z-score is. And z-score should be used for what kind of data? So z-scores should be used for what kind of data? What kind of data are z-scores properly used for? We could make this the standard normal. So the standard normal right here would have 0. I shouldn't draw it on there. I don't want everyone to think every normal curve is the standard normal. Standard normal has 0, 1 on it. So that would be the standard normal curve. Quantitative, nice job, Danny. 100 points right there. Z-scores, well, is used for quantitative and normal data. So if you notice, this has the normal shape right here. And so this is when z-scores are properly applied, but great job, great work. Z-scores are quantitative and they're normal and only normal. So you can use them for skewed data because you can just do the mathematical calculations, but hopefully my color coding on this helps with kind of your notes to see when you would use certain terminology. If you have gaps, if you have outliers, if you have skew, you're probably going to use the median for the center. Kind of follow this down right here. If you're using the median, you'll use the IQR. So you would use, so IQR doesn't calculate z-scores. You're right. No, keep asking. This is where we work on, like making sure we understand the topics. Notice how everything here is blue, and I tried to keep it to the left side. So how would you calculate if something's an outlier using IQR and stuff? So we gotta make a little more room. So how would you calculate? Think about how you would calculate if something's an outlier using IQRs. 100-point question. This is something we actually mentioned this week in 320. How would you calculate if something is an outlier with IQRs? Nice job, Charlie. Definitely worth the 100 points right there. Amazing work. I'm rewriting this to be smaller so I can do it. Observation minus mean over standard deviation equals z-score. And then this right here, we would do a box plot. So we can draw a box plot. And the box plot, the box of the box plot is going to be right there. That's where the median's at. There's the bottom. And, if we put, let's do this. Let's put an outlier over here. And that's the outlier. Cool. And so we would have here the fence and everything that we make, like where the fence would be. So this would be 1.Q3 plus 1.5 IQR. And also technically the lower fence, which we can't see on here, is Q1. I don't want anyone to think that you can't have low outliers. It just depends on your data. High outliers maybe are more common. If we have time, could we go over how to make box plots outliers and how to determine if an outlier on the stem and leaf? Yeah, is there a specific homework question that maybe I can help with on that? I might do a little more tool 1 right here, and then we've got time, definitely. And then, because I think my meeting's at 1, and I started late, so I want to definitely hang up. Do not need to put in a screenshot both. Yes, Rebecca. Great question right there, Rebecca. Only the pivot chart. So only the pivot chart. So if you notice, and here, let me hop to the video. So if you have a quick question, if you have any question, ask it. And if it's like kind of just a general question, I will answer it immediately. So if you're watching right now and you're like, wait, what do I do for this? Feel free to just like drop that question because I'm going to show that real quick right here. And we will do some 474 in a little bit right here. But I'm just going to show the very end of, I forgot to, if you watch the video, I forgot to say on average I said it like once, and then I realized I was like, oh no, I didn't say on average all the times. I have thought about learning data science video ad. So let me bring this over here to the screen. And if you go to the very end of the video, once again, warning, Brian, I had fun making the fire text. Once again, warning, Brian is working a similar but different problem. He's also only doing one of the two charts. If you look over here at the end, this is what it should look like. So I can't stress this enough right here. At the very end, when you make your assignment, well, I'm like in the exact same spot. It's like I filmed from this area. But this is what you should have for your visualization, Rebecca. Something like this right here with the decimals rounded well, with a clear and easy to read graphic. Notice how this here could just be in the newspaper, and that's our goal. Make sure, we'll get a lot of screenshots. I mean, we understand where people make sure it's something you would send to the newspaper, that they're not going to have to like crop and edit it, because visualization skills are something we want to teach. We want to be like, okay, how do you display data well? How do you tell a story with data? And what does the data tell you? I put a weird formula, I guess, to find z-scores. Can I put it in here to make sure it works? Sure. Let's take a look at that. And then did I answer Danny's question fully? Was there make a fire intro? Wait, a fire intro like this? This is the fire intro I made right here. I made and then the text goes, and then it goes away, and then I appear. I'll appear there. we got other intros. We got a Stranger Things intro. I'm actually working on a fire intro, a Smash Bros. Fire intro. A test given to students, and the mean is 70 with a standard deviation of 3. Jerry scores a 78. So let's plug this in. You ready? So it says it's normally distributed, right? Well, we will assume. Well, you can turn anything into z-scores. It's properly applied when data is normal. But what would y be with Charlie's question right here? And then we'll do one of Danny's right here. We're focusing a little bit on tool 1 because I've done, 324. We'll do some 474, I promise, at the end of this. You sent you a picture of it because I'm confused on why my chart has a blank. Trace, I bet I can, if you still have it up, I'll answer in 2 seconds. You got it, Trace. You are next, Trace. And Danny, I think, close. I wouldn't, there's an error in your math though. The last error in your math should be 2 divided by 3. So do this though. Charlie, identify right now what is the score that the person got. What is the score, the observation? What is the observation the person obtained? What is their observation? 78. That's what y is. So they scored a 78. Now identify the mean for the distribution. What is the mean of the distribution? The mean of the distribution is what? The mean of the distribution is what? What was the average for the, yep, 70. Now all we're going to do is just take the difference between those numbers and we're going to divide by the standard deviation. Standard deviation was 3 for this problem. So the top of this works out to what? If you subtract these numbers, you simply get 8. And so what would that be right there? Does that make sense right there? Yep. And so all you're doing is seeing how far they are away. If you go back in time here a little bit, we see that we are just taking the distance these two observations are away, and then we're putting it in terms of standard deviations. So the z-score is just how many standard deviations is an observation above or below the mean. And Trace, do this right now. I think, Trace, are you working on a Mac? Because Macs, yeah, I think it could work the way you're doing it. You would just do, I'm trying to figure out how to work it that way. A PC. Do you see a drop-down menu on your pivot chart? Do you see a drop-down menu? Do I still have my video up with me? I need to pull up the video again. Okay, shouldn't have gone away from it. I'll show you where to click. I think we can fix it. And Danny, feel free to drop your question in the chat. Like if you have a specific one, that way I can like answer directly, or I could try to work some examples. Trace, oh, I'm literally watching a fire thing. Is it because I put fire in mine? It's ribs? Oh my gosh, they know that I want to go out and eat some food. How do they know this? Okay, so where you want to click on, I'll show it. Not there. 2 seconds. I should have just made a new pivot chart. Okay, cool. This will show it. Okay, so you have a blank, right? Now we can get Brian Inception. With your blank, go over here and click on one of these, if you click on one of these where the blank is at, you'll see it has multiple fields for you to select. It'll kind of look like the filter thing I'm doing right here. You'll see like multiple things to select on, and you can deselect the blank. Does that make sense? So you need to be on the pivot table, and you need to go to the drop down arrow under one of the fields. Then you need to go to select multiple items and deselect the blank. I don't know why it does that sometimes. I don't know. I've seen variation between Macs and PCs and everything. But does that work for you, Trace, right there? That should remove the blank. And it'll also update your pivot chart. So the pivot chart and the pivot table are connected. Once again, don't take a picture of your pivot table once you add your data table. Awesome, Trace. Danny, let me see here. Go over how to make box plots with outliers and how to determine if an outlier is on a stem and leaf plot. So let me kind of answer that directly right here. So Danny, we got your question. Outliers for stem and leaves. Go away, Brian. So let's go to a new sheet. No. There we go. So when we make box plots, we could start off here with some data. Let's do this. Let's do 10 data points and make a box plot. And this is something we don't put on the test. We care more about the analysis, but I'm going to do a rather quick kind of box plot example to see if we could make one by hand. So let's actually put in some low outliers this time. Let's go here 1, 2, 10, 11, 12, 15, 18, so there's 5, 6, 7, 18, 18. This is data on, I can't think how many cookies are left in a bag of cookies. So someone came in and ate all in the other ones. Oh, we should put a 0 then, obviously. Cool. This will be 1. They were nice. They left 1. It's a bag of 20. It's one of those rose things. It's Girl Scout cookies. It's the Thin Mints. We figured out what this problem is. And there's 20 Thin Mints. This is you go and you look at the stack of Thin Mint cookies, and it's how many Thin Mint cookies are left. Someone collected data on that. We know what this data is now. It has context. It's one of those, does everyone know what I'm talking about? The Thin Mint cookies? Oh, no, Girl Scout Thin Mint cookies. So how do you find something at the 80th percentile? We'll do that. We're going to do that problem next, Charlie. We're going to do an extension of this problem with that, you bet. So let's do this right here. And I'll show that, Charlie, in this video, which is good. I bet you're working chapter 5, part 2. So with this right here, and great job, Charlie, working ahead right there, because I'm going to cover that a lot next class, but don't worry. I'm going to show how to do that. So this is how do we make a box plot from this data? Let's label this. How do we turn this into a box plot? Yep. Visualization number 5, video, 2 seconds. It'll be in the visualization playlist. And so this should, oh, that's 4. We're going to turn this data into a box plot. We're going to turn this data into a box plot. This data right here, we have to think about how to turn it into a box plot. And the way we're going to turn this data into a box plot is we first need to identify the what. Someone help me out for 100 points. We need to first identify the what to turn this data into a box plot. What do you think we need to do to turn this data into a box plot? Identify the what. Not the mean. Good, Wilson right there, 100 points. We need to know the median. Brian's giving a hint right here. We need to really know the what to turn this into a box plot. The what. To turn this into a box plot, we really need to identify the what. You're right, Charlie. Yep. Basically, people are giving a lot of the answers. We need to identify, let's first identify the 5-number summary. Charlie, 100 points right there, and Wilson and Gigi for asking some questions right there. In the min and the max, Danny, 100 points. Now we've given the 5-number summary right there, 5-number summary. How do you memorize the 5-number summary? This is a review of the 5-number summary right here. The quickest way to memorize the 5-number summary is to go here and draw 4 quarters. What? That's not the 5-number summary. Once you draw your 4 quarters, you can identify all parts of the 5-number summary. Now, the easiest ones to remember are the min and the max. No one's forgetting those. And then we learn the median as we go through school. So we got here the min, the max. See, look, I'll even get something wrong. The max. And then we go here and we have the median. And now we go here and here. How many quarters do we have here? It's already in the chat, kind of the answer. How many quarters do we have there? And that kind of tells you what Q1 means, what Q1 represents, that you've gone through this percent of the data. We have 4 quarters on the screen, and at this point, 100 points standing right there. At this point on the screen where the highlight is at, we're at how many quarters through the data. So at this point, what we've highlighted is we're at Q1. Nice job, Danny. Another 100 points. Great job, Danny. So Q1. And then here we're at Q3. And just think about what these things represent. Q1 represents the 25th percentile. Q3 represents the 75th percentile. You can just kind of see this as you move through the data. Now, there's a lot of, I'm just going to say this, the easiest way to get the, what about the hand trick? Which one? Which one? Oh, this. This is the 5-number summary right here, which the quarters would be between your fingers right here. If you're wondering about that, like, is that what we're talking about, Charlie? I'm going to find out the answers to this data. Yeah, and so, and we could ask you the median of this data. 1, 2, 3, 4, 5. Of course I did that. Cool. Who knows the median of this data? This is a very fair test question. This is a very fair test question. What is the median of this data? See if you can take a moment right now, find the median of this data. It was fair before, but if you know how to find it right now, yep, 13, because it's between these numbers. As you notice, I knew there was 10 numbers, so I went 1, 2, 3, 4, 5, and I was like, okay, it was 13.5 before I changed it, but since there's no middle number, the median is now 13, and this looks to be where we can make some changes again. Let's do that, and cool. Okay, we will never ask you to find Q1 or Q3 on the test by hand because there's different formulas, and here's something I would do. This is how Brian would go ahead if Brian really wanted to know the 5-number summary. If Brian wanted to know the 5-number summary, he would go here and he'd take his data and he would just do this. He'd drop his data there and he'd go summary. There we go. Oh, wait. Oh, I'm still running core demo. So there we go. Core demo. Finish core demo. There we go. Here's the 5-number summary, and I kind of set it up to be this way. So you can see the 5-number summary on my screen right now. So, oh man, we don't have any outliers. We can fix that though. This is our studio. So this is our studio. And if you notice, I was easily able to save my data. I had already written it with commas, and I just asked for a summary. So Charlie, here's the really cool thing. If we're actually working with real data and I want the 80th percentile, that's a graphical thing. It says out because of this right here. That might fix it. But there's the 80th percentile of this data instantaneously. We don't use it in 201 if we did this. So if you're wondering, wait, Brian, why are you doing it this way? You could go to jump and do it. So here's how we would do it in jump. And I'll just do kind of a similar, but might be slightly different data. Inside of jump, you would go here, you would enter in your data. The reason I did it was I wanted to use R was quicker for me to actually paste the data in. So whoops, you could have this many points, and you'd go to analyze distribution, you double click, and now you get the 5-number summary and all this good stuff right here, and you even get the box plot. But, and this is kind of, so this is how you would do it inside of jump. Did everyone see the steps? You'd input your data, so you could call it Girl Scout cookies, and then you'd go here to analyze distribution. Once you go to analyze distribution, you double click, and this was visualization number 2. So everything you're doing right here is in visualization number 2. If you need to review that video, I hit the wrong button, and we go right here. So this will create the visualization and everything. But check this out. I bet people know how to code. You're like, Brian, this is crazy. What do you think I should start typing to get a box plot? Does anyone know what I should start typing to get a box plot in 201? 201ers, 500-point questions right here if you help me make a box plot and a histogram. What do you think I should start typing to make a box plot and a histogram? Who knows? Plot might actually do it. It's going to make a time plot. We're close. That made a plot right there. Let's start typing box. Oh, wait. Box plot. Whoa. What should I start typing if I want to make a histogram? It's just hist, and I clicked the wrong button. Ah. I brought a narrator in. So here we go. And you can go col equals FF8200. That's hexadecimal. That's UT orange right there. So as you can see, and we just did a little bit more fun with it, but you can make the box plot right here, and you can also use the same thing right here. and go there, and you can add in your colors and everything. So you can make a box plot pretty easily in this program. You say, make it box plot on my data. The content quiz, and it's the 80th percentile. You bet. We're going to do that next, Charlie. You got it. So we're going to make this box plot by hand right here, and then we're going to do Charlie's question. You got it. So let's hop back here to this box plot we are making by hand. We've identified the 5-number summary. So we were able to identify the median on our own work. It was 13. That's something you need to be able to do. The median was 13. It was the average of the two middle numbers because there was 10. So we had to average together the 5th and the 6th number. This was 18. This was 10. This is 20, which is behind my head. This is 20, and this is 0. So when we make this box plot right here, let's draw a number line. On this number line, we're going to start with 0, and we're going to go to 20. And then where do we draw our box? There is a small little fly. Go away, fly. Where do we draw our box? Where should our box be? Where should the box of the box plot be? The box of the box plot will be where? The box of the box plot will be, and that's not properly to perspective. This one down here will be, yep, Danny, great job, Danny. It'll go from here to here. There's the box of the box plot. And then the median will go right here at 13. So that's where 13 is at. And that's where 18 is at. And then the max goes here to 20. But look at this. Will 0 be an outlier? Will 0 be an outlier? And the answer is no. So the fence is invisible. The fences are actually invisible. We really never see the fences. Like, you should know where the fences are. They're 1.5 IQRs above Q3 and they're 1.5 IQRs below Q1. So where are the invisible fences right now? Can anyone tell me where the invisible fences are? Here, let's draw the invisible fences. One of them is about here. And the other one is all the way over here. Does anyone know where the invisible fences are? It'll be an outlier if it's more than 1.5 IQRs. So the outliers begin at Q1 minus 1.5 IQRs. So that's how we know it's an outlier. On the low end, if it's outside that fence, you don't usually see these fences. We erase them after we draw them if you're drawing one by hand. And then it'll be an outlier on the high end if it's more than Q3 plus 1.5 IQR. So Danny, amazing work. Danny, you're right. Danny, you're completely right. And so what if? So let's do a what if analysis here. What if we had a Girl Scout pack of cookies that somehow had 31, like it was like a mega pack. So now we've got a Girl Scout pack of cookies that have 31 cookies in it. That should be an outlier. So 30 is where the upper fence is. And we don't actually see those. They're just a drawing technique. You'll see the blue thing in the graphic right here. This is the cool thing about using software like Jump, is I can go back here to this data, and let's do this. We're going to go right here, and we're going to change the maximum to 31 right here, and let's take a look. And let's make this one 20. So now we have basically the same data, and now look at it. Does this look a lot like what we drew? And actually, you know what? I can fix it, because there's an additional argument. Horizontal equals true. Does what we drew right here, let's take a screenshot of it. That's why I like I like our software, because you can be like, here's what I want to draw. Does what we drew here look a lot? Cool, we'll put it right here. Do these things look very similar? Oh, because that. Can we get them both on the same screen is the question. I think we just did. So close. Do these look very similar? And they should. There we go, that works. So if you notice, this goes from 0, and the line right here is at 10. This is at 18. This goes up to 20, and then you have this right here. I'm going to distort the graphic. You should not do, oh, actually, no, it doesn't hurt it that bad. You don't usually grab them like that. And aside from me not being able to, I wasn't able to go out far enough on that axis, but this is how the box plot looks right here, and you're seeing similarities between what I drew by hand and what's right here. Does this make sense how we drew it? Is everyone kind of on board on what happened here and what the graphical software did, where it's putting the lines and my best artistic attempt at one of these right here? I would expand it. Once again, I just want to say this. If you expand graphics, you should always expand them here to keep the aspect ratio, but it would just kind of make it, oh, I could try to overlay it. Wow, proud of myself. Except for the outlier, which is off the screen, not bad job right there. So you should always grab. And so just understanding how the software did it and the outlier's over there, that's where the outlier is at. We could also confirm that the upper fence is at 30. Watch this, and this is why I love using software. If I go here and I change that highest point to 30, watch what happens. Scroll. This is no longer going to be an outlier because it's right at the highest fence right there, and you see it's no longer an outlier. But what happens when it's exactly above it? Watch this. It's just barely above it, and it's an outlier now. Does that make sense? This is a gap in the data, and 30 is as high as the whisker can go. The whisker can go as high as 30. We'll get it so it runs it. So the whisker can go as high as 30. The whisker cannot actually go to 31. I'm running the two lines of code at once. So if the data is 30 point this, which is just barely above, it'll be an outlier. But if the data is at 30, it'll not be an outlier. So there is an invisible fence right there. Invisible fence. There's the invisible fence. Who's with me on this? Did people kind of understand what's going on? You don't see the fence. You don't see it. Really good, really tough stuff right there. I understand this is the topic where people are like, wait, where's the fence at? You don't see it. You don't see the fence. When you draw it, you erase them, but if you're doing it by hand, you will. And so I think Charlie had a really good question. I'm going to break these headphones too, and that would not be good because these are the only headphones we have for two people. I saw some $200 headphones yesterday, and I was like, I want to buy those. I'm kind of scared because they're like noise, like they're like complete noise isolation headphones. So I'm like, do I want like to have complete silence and not hear the outside world? Because I mean, sometimes you want to hear what's going on. You want to like be like, like know that like, I don't know, your fire alarm's going off or something. You're like, oh, and there's something I should respond to. Oh, awesome. Is like, anyone ever see the Schwarzenegger meme? We should make that. I need to put that. We need more memes. So let's take a look right here. Oh, perfect, Charlie. You are awesome. Charlie says that a distribution is normally distributed. It looks like temperatures to me. Charlie, is that 0.07 or 0.7? From what I know with these sorts of problems, I'm assuming that's 0.7, not 0.07. And I'll show you why right here. 98.2 sounds like the temperature to me. And then the standard deviation would be, no, don't worry. Don't worry. 100 points, Charlie. Thank you. One thing I don't like about this applet is sometimes it doesn't show you the upper one right here. There's another applet that's really good though, but it's got its issues. There's no perfect applet except for the one I made, that DigitalOcean. I don't know. And also I had help making it. Someone helped me make it, and real big thank you to, can't think of his name. That's really not nice of me. But he helped me make the applet. Here's another applet I like, though. This is statdistributions.com. Drew, who is really great in mathematics. Drew helped me make it. He did a lot of it. So these two websites right here, we'll drop them in the chat. This is the David M. Lane website, which is probably the best for the homework. The David M. Lane website. And this one right here is really good for sending like pictures. Do we need to use that? Yes. I do not do these by hand. Do not do these by hand. And for the test, everyone always wants to know, which is a great question. Well, how would I be tested on this? So we're going to answer your question right here. And it says that the middle 60% is between this and this. What adult body temperatures is the 80th percentile? So let's look at what this graphic shows us right here. I'm going to go here and go to middle 60%. And we'll talk about how to solve this question right here. So let me point something out. On this button right here, you can pick to do a value, an area from a value. So this will always return to you an area under the curve, like how much of the curve is shaded. On this one, you always get a number on the bottom of the curve. So we're going to tell it the area, and we're going to say between. And then if you notice, look at that. We're getting these right here. And oh, it's telling you the z-score down there? Okay, it's telling you the z-score. But guess what? We don't have to worry so much about that because we can go right here and go 98.2 and 0.7. Boom. So what adult body temperature is the 80th percentile? Now, here's what we need to do. This is how a test question could be. It could show you all this information right here. Does this make sense? This is where the middle what is. And let's take a picture of it. Right now, Brian has shaded the middle what. Just so we remember, Brian has shaded the what. What has Brian shaded right there? The middle 60%. Immediately when you see this, and this is how to ace these questions, go right here and immediately write the numbers on the curve that you can identify. The numbers we can identify on the curve are going to be 60%, and we can identify 20% here and 20% here. So we know right now that this is the middle 60% of the curve, and that's the upper 20%, and on the bottom is the lower 20%. Well, we can go to the bottom of the curve, and we can write 20% here. That's the 20th percentile. That's the 50th percentile right in the middle. But what's this line right here? What percentile is this? What percentile is that right there? Anyone know what percentile that is? That's the what percentile. And percentile is like how high are you on the curve? Like if you're at the very top, you're at the 100th, and if you're at the very low, you're at the 0 or the bottom or the 1%. So depending on where you're at from the top or the bottom of the curve, that's your percentile. So, and I shouldn't, that looks like it's showing something it's not. Putting a line right there. With my highlighted mark, well, think about this. This line right here, this blue line is the 20th percentile, and then we would go through the 60th to the next line. Well, so, but look right here. So we right here, so we got to play it. Look at this graph. So with this right here, we're at the 20th percentile right here, and we'd go through 60% of the curve, and where would we be at here? If we're at 20% here, and we go through 60%, and where would it be right here? You're right, Charlie, because how much is above the 80th percentile? At the 80th percentile, how much area is above it? At the 80th percentile, how much area should be above it? And that's another way to kind of figure it out by just looking at it. You can be like, wait a minute. At the 80th percentile, but what is that line? It represents kind of the, I don't see an exact number here, but, I mean, it looks to be a little bit below 98.9, right? So when we think what the answer should be logically, let's just logically think about the answer. Logically, the answer should be something like 98.8 or something like that. Like 98.8 should be the answer. Let's go back over to the curve right here and see that we have two. Wait a minute, that looks like 98.8. This tells us on the David M. Lane applet where this number is and where this number is. We could have also went here and just asked it, what's the 80th percentile by saying the area below? Notice how this is in the same spot and it's doing 80% below this line and 20% above. You can ask for any percentile on the David M. Lane with this part of it right here where you just put in the percentile and you put in the numbers and it shows you where it's at on the curve. Notice how I raise this and it starts going further over. So the further over you raise it, the further over it goes on the curve. So what if it asks for the percentile? It's all the values below. So no, imagine if I said, Charlie, great job on the test. You scored at the 90th percentile. So let's look at the test right here. The test had a mean of 80 and a standard deviation of 10, and you were in the 90th percentile. That's where you scored. Charlie, you scored a 92.8. So this would be your score right here. The 80th percentile would be students who scored a 92.8. Great job. So, or Charlie scored in the 95th percentile. You scored in the 98th percentile, the 99th percentile. I mean, look at grades, amazing grades right there. So the percentile on the curve would be the area to the left of it. So if you're at the 99th percentile, you'd make 103. So if you're doing the top 10%, that'd be the what percentile? Great question, Charlie. If you're doing the top 10%, what percentile would that be? If you're doing the top 10%, you'd be in the what percentile? You got it. But you know what? You don't have to do it this way. You can go here and ask for the top 10%. Notice now the way it's shaded, which is an important thing to understand for the test, that if you're looking at the shading right here, this is 10% with 90% below. So this is the 90th percentile. Ignore that 90. That 90 is just happenstance. Now we're going back to Girl Scout cookies, and now the 90th percentile is here. The 90th percentile did not move as I changed the context of the curve. And one thing I know is that the 90th percentile will always be at 1.2818. So let's go right here and see 1.2818, and it's rounding it because it rounds it up. But I know where the 90th percentile is at. I know the 5th percentile is always going to be at 1.645, and I know the this percentile right here will be at 1.96. Very classic statistics number. Anyone, if a stat person's watching, like, yeah, everyone knows 1.96. So I know where these spots will be at on these curves, and it doesn't matter if we change the context back to the test. If you notice, that line never changed because we're always shading the top 2.5%. So using this applet right here, people used to use z-tables. I'm very against z-tables. You can use these applets, and I always point that these things right here, I should still have it on my phone. Did I remove it? No way. No, I didn't remove it. Why would I ever remove this? I have to download it. I am so low on space on my phone. Yes. I have this exact same. You'll barely be able to see it maybe. Can we see it? Oh, it's so hard to see with the bright screen. You can't see it. I swear to you. I promise you. It's on my phone. The normal curve is on my phone. You can't see it. Oh, you can see the entry things up. Well, you can see the curve, I think, just barely. So anyways, long story short, people always say, well, you don't always have a computer. I'll be like, well, I always have my phone. And I always have some of the numbers memorized in my head. So if I really want an exact calculation, I'll use a computer. Last but not least, if you do have a computer, there are ways to do this. You can do QNorm, and you can go right here and actually get, why do I always forget QNorm? QNorm is quantiles. So this will return 1.96, but it'll be 1.9599. There we go. So this will get you the exact calculations. So what makes you shade above or below? That's what I'm confused about. Like, what is the 80th percentile? So anytime we're talking percentile, you'll always shade. Generally, when you're doing percentiles, you should always shade to the left or to the right. What makes more sense with percentiles to shade to the left or the right? Like, what makes more logical sense with a percentile to shade to the left or the right? What is more logical with percentiles, to the left or to the right? Like if I say the 80th percentile, is it more logical to shade the left or the right? Wilson, great job, 100 points right there. Wilson, you're right. If we're talking about the 80th percentile, it makes more sense to shade this right here because that's kind of like 80% of people are below you. Does that make sense? It's like there's 80% of the class that's below you if this is test scores. But you could, there's many ways to get the 80th percentile, and this is where we get to some of the harder test questions. Is Brian currently, 2 seconds, I'll do it this way. Is Brian currently shading somewhere where could you find the 80th percentile with this graphic? With this graphic right here, could you find the 80th? And yeah, you could. Could you find the 80th? That's the answer. Could you find the 80th percentile with this graphic? And how would you know on the test if this graphic could get you the 80th percentile? Once again, we need to go back here and we need to label it. Pretend you got this on the test. The first thing you should do is go here and label it. What is the white area right there? How much is the white area? Well, that's the harder question. How much are the two shaded areas right here? I'll do that one next, Charlie. How much are the two shaded areas worth right here? The areas that are shaded are worth how much? Charlie will do that one next. I switched the questions so much, and so I might explain. The two shaded areas are a combined total of 40%. My fault on this question. 20% each. Danny, you're 100% right. Danny, 100 points right there. So that makes them each 20% of the curve. And that makes this 20% right here. And you can quickly deduce if you've done a lot of these problems, well, if 20% is above here, then 80% would be below here. Does that make logical sense to everybody? You could also figure out that if 40% is in the middle, that's 60%. And if you notice, if you add through this would add up to 80% right here. So there's a few ways to do it, but understanding that, is this making logical sense to everybody right here? And maybe I'll draw it this way right here where the numbers add up to kind of show it with colors and everything, that if you know that this is 20% right here and that there's 20% above here, well, then there has to be 80% below. But you can also label the whole curve and figure it out right here. So the 80th percentile people scores is kind of close to that, Charlie, kind of close. The exact answers right here for the 80th percentile for this problem, if this was a problem we had, the exact answers would be this right here. So you see how this gives you, it's kind of close, it's a little bit below that, but the 80th percentile is going to be this number right here. The percentile is this. This is currently showing the middle 40%. The middle 40% of, or the outside outside 40%. Oh my gosh, sorry. That was an error. The middle 60%, the middle 60%, and I'll show it a little bit easier to understand what it's showing there. Now it's showing the middle 60. Whatever is here is the shaded area. Yes, Charlie, that was, oh, counter's not on. 2 seconds. Oh, look, it didn't count it. Ha ha ha. Okay, try it again. Try it again, Charlie, it'll work now. So if someone says you're in the top 20%, you could. And Danny, great job right there. So if someone says you're in the top 20% of grades, they're telling you that you're at the 80th percentile, but they're kind of talking about it this way, visualizing it. Mubot, you're going to come after me here, aren't you? It's errors. It's errors. Sorry, Charlie. It's errors. So I made that mistake too. Sorry about that. So it's over there. So with this right here, this is the top 20%, but it could be displayed the same way as the 80th percentile. Does that make sense? It could be displayed as the 80th percentile, or it could be displayed as the top 20%. Is everyone on board with this right here? That you could say I'm at the 80th percentile, but you could also say that I'm in the top 20%. And sorry, like ignore the graphic for a moment. There we go. So either way is correct to display it that way. So will we have the exact numbers for the test? So what we'll do, so there's 2 ways we generally do test questions. So the 2 ways we do test questions is, one, to give you the empirical rule. So we might give you empirical rule numbers. Like here's a very fair test question with empirical rule numbers. Let's, we don't have the same numbers. So here's a very fair empirical rule test question. So this is something like use the empirical rule to solve for the answer. So let's do a pretty easy one right here. Use the empirical rule to solve for the answer. What percent of students make between a 70 and a 90? And we might not even show you this graphic. We might say grades are normally distributed with a mean of 80 and a standard deviation of 10. What percent of students are, according to the empirical rule, are expected to make between a 70 and 90? And if you know the chapter well, this is like, boom, boom, Charlie, you got it, 68. Now it's very close to 68. Don't worry, this said use the empirical rule, but this is where we use the empirical rule. Now we do a slightly tougher empirical rule question sometimes on the test where we ask something like, let's just do, this is like a level 3 question now on 10, on like a difficulty scale of 10. And it's maybe like a level 4. What percent of students are expected to make between a 70 and an 80 according to the empirical rule? If the question says use the empirical rule, use the empirical rule. If the question says use the empirical rule, use the empirical rule. Close, Wilson, close. So remember to use Charlie's answer right here and look at the difference between this answer and this answer. Yes, yes. And I know why you're thinking 32, because you're thinking of, here, I'll show it visually. You're thinking of the outside of it. And don't worry, like, because we just did the outside of this is, so there's the inside 68 and there's the outside 32. So you were thinking of that, but we were taking this and cutting it in half right here. So, and great job, Wilson, 100 points. Great job, everybody. Got like 10, 15 more minutes. And 474 and everything. We will do more questions. I might even do some Twitch this weekend, maybe. Might do some Twitch streaming. The multi-streaming crashes me, and I don't know why. I don't know if Twitch and YouTube are getting mad, and I'm a little afraid of it until I figure out why it's crashing. Less YouTube and Twitch are like, you can't do this. And I'm like, oh, I didn't know. I don't take my channel. Let's do a really difficult question. What percent of area is between 50 and 70? And this is, what about a Zoom? As in, what about a Zoom? What about, like a Zoom session? I like these because they're recorded. And that way, I do meet with students on Zoom. If you want to meet, like if, do remember that, like if you were like, instead of Twitch, well, with doing it on YouTube, this will be recorded so people can watch it later and the office hours and I can upload the Zoom. I know students don't like appearing on recordings, so lest I do Zoom meetings and then people talk and then they're like, I don't want to be on YouTube. And I'm like, I don't want, I'd understand if someone said I don't want to be on YouTube, because a few students have contacted me and like, I don't want my name on YouTube. And so I say, yeah, use a fake name. Yeah, no, Wilson, I'm throwing 1,000 points. Please like give me these suggestions or ideas. And, yeah, no, and I will meet with students on Zoom. That's actually what I'm doing here in 15 minutes is I'm meeting 2 students at 2 separate times. So I will meet with students to like talk over things and explain concepts a little bit more. And so, especially if you have concerns about the class, that's like the number one thing I'll meet with people on Zoom. Like, Brian, I'm completely lost. And like, can you help me out? I want to do everything. Yeah, and I hop on Discord voice chat too. So Charlie, yeah, you're on the Discord, right? I don't stay in the voice channels because a lot of times I'll be typing emails, and the first week or so I'd be in the voice channels and I'd be like I'd just be like typing emails, and you just hear like Brian typing like crazy. And so usually message me, and I can hop into a group room. And so I'll usually hop between rooms, but a lot of people message me and they say, "Hey, can you hop on voice chat?" And that's pretty much the quickest way to get me on voice chat. Is there a way to rewatch class videos? You bet, Victoria. Let's show that real quick right here. If you want to rewatch class videos, and I'll show. I'm not going to post the link in the chat because we're on a public video right now, so don't post the public thing. Since we're on a public video, because we don't like the random people who come out. So right here, you'll notice there's the watch class live button. So to rewatch class at any time, just go to the, I know it says watch class live. Maybe I should also change it to watch class live / class recordings. Oh, you did? I'm always on Discord. I'm always around Discord. Like, and so to Victoria, does that make sense? Go here to the watch class live button and click that, and it'll have the recordings. So everything there is like, it's all linked. So you can rewatch it. You're welcome, Victoria, 100 points. Thank you, Victoria, for asking that. If I had a specific question, could we set up a Zoom? Yeah. Definitely. Wilson, yeah, maybe I'll hop over there. Are you free right now, Wilson? We might end office hours right now, and I could do that real quick here. We could jump straight to a Zoom because I think we're kind of winding down. We've got a more difficult, we'll finish with this difficult question right here. We did some really good normal model stuff. Really great. Glad to see so many 201 students here. BAS 474. I love all my classes. But I was worried about because we weren't doing as many 201 questions on office hours. And I was like, I know the content's getting more difficult, and I don't want 201 students to feel afraid to come in here and ask questions. So I know I focused a lot more on 201 today because I haven't done as many office hours for 201. But if you're here, I'll answer every question, and I'll try to, we'll stay focused on as many as we can, and I'll try to help out everyone. And I really appreciate everyone swinging by. Like, I want 201 to know they're very welcome to come to office hours. I don't want them to see me working on R and be like, oh, he's not doing 201. Oh, yeah. Cool, Wilson. You know what I have a question about, though? Wait, yes, he's free. I'm roommates. Wait, I am so confused, Charlie. Wait, what's that about? I'm so confused. So with this right here, who knows the area under the normal curve here? Oh, Will. Oh my God, that's too funny. That's hilarious. Who knows the area between 50 and 70 according to the empirical rule? Who can estimate that? He's doing nothing right now. He's watching the stream. 2BS on right now. That's what they call me. Brian Stevens. Who knows the area under this curve right here? You know what we could do? Who knows it? I'll show how to do it. It's more difficult. You have to notice that this is not being, it's very, very close to that. And you know what, Charlie? It's really, so this is like kind of a mean test question because it's basically 16%. We can see down here, it's basically 16%. But notice how this is not shaded right here. Charlie, that's worth the 1,000 points of the week. You are right. You identified what this area was right here. Yeah, no, you got it, man. You did it. Yeah, you figured out it's such a mean test question. But it's about as hard as we can go with empirical rule type questions. And I'm just going to show how Charlie got that answer. If anyone's rewatching this and wondering how Charlie got that answer, what Charlie did is probably the quickest thing to do. Like a quick way to solve this is to understand. You could understand that in between here and here is your 68. I should draw that up higher. So you've got the empirical rule, which is estimates of the percentages contained within certain standard deviations on the curve. And within plus or minus 1 is 68, which means outside is 32. You take that and you cut it in half. No, that was an empirical rule question. Oh, yeah, I know, right? Mubot knows about that right there. I'm forgetting. It's not that. It's this. I know it. I know this. That's it. Right, Mubot? Mubot. I don't know where it's at. We have so many quotes now. And here's where you have to subtract off this little bit. Little bits. We're only missing the 68 right here. I try to focus when I write, lest my handwriting just be horrible. Wait, why is it? Because that's the exact. There's decimals we don't see. So if you want to get more exact on this, so here's the empirical rule. I'm gonna put a big like. I wish I could like flash a warning thing, like Brian's about to do something you should not do, and I'm gonna do that here in a second. So here's the. I got enough time. Here's the empirical rule, and the reason we get this area right here is because you would take between these two areas, and this is according to the empirical rule. That is the empirical rule. Do not, Charlie. That's awesome. See, I just need to make it like warning Brian's about to do something you shouldn't do. I could literally make that appear. Like I can make rain appear right now. I can make my sad music appear. I just forget where my sad music's at. Sad. So, oh, and then I know what we have there. I need to label my buttons. So I'm like, because I'm always switching about make it with fire. Oh yeah, no, we will. I could get it done today because I know how to do it. I can show you guys those things I'm working on. But it's really kind of fun doing these things. Like I'm learning how to use more programs. I'll pull that up right here. We'll show this at the end of office hours. Okay, let me pull that up. I'm pulling up After Effects. So After Effects is how I make all the different graphic things that we're making. And so I'm, trying to, I did tweet Keanu. Well, I don't think he has a Twitter. I tweeted him, but he just has like a hashtag. And then there's like an official Keanu and it has like 10,000 followers. I'm like, I don't know if that's the official Keanu. I have Text Explosion that I was working on. So here's one of the graphics right here, and it goes. So this is something I was working on right here. If you just watch the animation of it, so you have to put in like your keyframes, you have to put in the effects, you have to do different things, and it goes. So I was thinking, I don't know. So yeah, we need a better way to get a hold of Keanu, but this is After Effects. It's just fun to watch it, and then there'll be music playing. But so kind of those things there. Yeah, no, After Effects is a lot of fun, and I'm learning more and getting better at Adobe Premiere. Thank you, Danny. It's just practice. It's just I'll watch a bunch of YouTube tutorials and be like, okay, how do I do this? How do I do that? And then the text explosion thing was kind of an idea I had on a whim. I was like, wait, if it just went like that, and then I was gonna have like Stat 1 display, and I might do that for a video. What are the points after? Oh, let's end class with this. We're having a little fun here at the end. So this right here is 99.73 if you carry out the decimals. And this here is 28.26. I always get that one wrong on the second decimal, I think. And I'll show you something real quick. So think about this. 100 minus 68.26. That means that area down there is half of that, and it's 15.87. And 99.73 means that that area down there is actually 13. How is it? Yeah, I know the empirical rule is a lie. And so this is, we're ending this stream here, but we're not done yet. Okay, let me erase these other numbers. So now we just have to subtract these two numbers here. And if we subtract these two numbers, we're going to get much closer to the actual answer. 15.87 minus 0.135. And that's 15.73. And so now if we go and look at the answer on the curve, the answer Brian calculated with his numbers is almost that to the decimal. I'm having trouble with Visualizer 5 with adding the elements to the chart. Yes. I've got an additional video for that. Let me show you. Let me send that in the chat. 2 seconds. It's on, if you're on the playlist, it's a really good question. Oh, I'm right here. Good. Because I didn't know Macs were different. There you go right there. That should help with that right there. That's how to do it right there. Click the chart. Click the chart. So you want to click, I'll show it in the video. Open new tab. Cool. Okay. So what you want to do is you actually want to make sure you click on this, and this will change the options right here. So make sure you click on this, and because if you're not clicked on it, you won't have these tabs up here. There's no green bar for me that says I might have to see it, GG. It should be there if you click this, because I went over to my Mac and just took a screenshot of this. If you click it, the chart, then it should open up all this right here, and you should get these options. It should do it. Oh, Charlie, you might be right. GG, is that true? You might have to hop over to there. And I'll show some last things right here. Use the, like download it, use it on the computer. The online version might not have it. And I could look into the online version and maybe see if I'm just not familiar with it. Yes, you have to download it. Wilson, 1,000 points right there. Thank you, Wilson. I appreciate that. People helping me out. And I really appreciate it. So the last thing we'll mention right here is this. So someone said, I think it was Charlie said, what are the percentages on the curve? So if we look to where the middle 50% is at, so here we'll write it out real quick right here. The middle 50% takes a second, but it's free. Yeah, it's totally free. So I think it's worth it to download it. So here are where the z-scores are at. And these are the numbers I know on the normal curve. The percent, wait. This is the percent right here. So let's do it as a percentage. No Office, yeah, like download No Office, you're correct. So you'll go to your Outlook and you just log into Outlook and it's in like your tools, right? I should make a video on how to do that. I should focus on this, sorry. The percentages I know are not as important as making sure someone has. So, yep. So you'll go into your Office 365 and then you'll see like download apps. It'll be up here, GG, somewhere. When you log into UTK and you see Office 365, you'll see like download apps in the top right corner, I think it is. And then you just download and it's not that big of a file. And then you have them on your computer and it's easier to access. So I'm asking, I know you're, oh, no. We were kind of done. It says install Office. I was going to show off the numbers I know on the empirical rule, but that's not, I was going to play the sad noise. No, this is more important than Brian being like, here's all the numbers I know, because you teach Statue 1 for a long time and you memorize numbers. So, but it's not important that you memorize numbers. So it's more important that we make sure you have Office and you can do the assignment that's due tonight. Any other last questions? I want to make sure we focus on the questions and we make sure people have the help they need, because that is way more important than Brian being like, at 68.26%, we are at 1 standard deviation. At 80%, we are at 1.2816. I used to get on wrong. At 90%, we are at 1.645. These are the z-scores here on the other side, or 1.6449. And then 95% is 1.96. It's 1.9599. 1.9599. And then 98% is 2.3263. And 99% is 2.5758. And then people know 99.7 is when we were at 3 standard deviations. And then you have to memorize that 4 is, or 99.99 is 4 standard deviations out. 99.9999 is 5 standard deviations. And 99 point. Each time now you add 2 9s, so you go 999999, and that is the 6th. And on the 7th, 2, 3, 4, 5, 6, and then you add 1 more for the 7th, and that makes 9 9s, which is an interesting pattern, I thought. And so I'm pretty sure this is correct, and we could check one of these right here by going to the 99.99th percentile and see if we're near the 6th standard deviation. And what are we going to use to end class? We're going to go back to here, and we're going to enter this in, and we're going to move the decimals, and let's see if Brian is right, that this should be near a z-score of 6, because that's the quantile. Wait, because this is the percent between it. So we want to, I'm just making sure we do it correctly right here. It's the last thing, because that's the percent between it. So on the outside of this, we do 1 minus this, and that's the percent outside. So that's the percent outside, divide by 2, and that's that. So that's the area on the outside. So we want to go to this plus this, and this is Brian's guess. This is the end class. Some fun here at the end. Brian's guess. I'm saying that this should be 6. Let's see. Very close. Very close. It's a lot. There's maybe other decimals I don't know, but that's close to 6. And so that was close to 6. Should have been closer. Is it working, Wilson and Gigi? That ends it. I'm going to hop over to a Zoom meeting. Sorry, I was just having a little fun at the end there. Thank you, everyone, for helping Gigi. If you are here, you get 1,000 points for the week. I'll try right now. Thanks. Email me if you need help. And Wilson, thank you so much. Wilson, great help right there. Email me, Discord, everyone helping out. Mubot knows what's going on right here. Mubot, end us strong with a good quote. You know what's going on. 1,000 for the weeks, max. You know what? 1,500 for, I'm going to pick two people right here, Wilson and Gigi, for the huge help right there, for helping each other out. Mubot, Vols help Vols. Mubot knows Vols help Vols. Thank you, Danny, for being here. And thank you, Wilson and Gigi, for working together and helping each other out. Vols help Vols. I will see everyone later. And email me if you have questions. Discord me if you have questions. I will see everybody later. Bye, Wilson. Bye, Danny. Bye, Charlie. Bye, Gigi. Bye, guys. Bye.